Hello, everybody. Hello, everybody. Can you guys hear me okay? Or am I reverberating? Can you guys hear me okay? Or am I reverberating? Do I sound like there are two of me? Or am I good? Do I sound like there are two of me? Or am I good? Oh, there's two of me? Okay. Let's see if I get rid of this. Let's see if I turn into this. Is that better? Is that better? This is gonna be a fun one. Oh boy. Okay. Hang on, let me see if I take off this headset of mine. Hang on, let me see if I take off this headset of mine. Is that a bit better? Can everybody hear me okay? Is that a bit better? Can everybody hear me okay? Am I good? Okay. Just want to be sure there's not two of me, because I had issues last time. So, just want to be. Yeah. Technology. Alright. Can't hear you without it. Alright, looks like I still got some audio issues. Bro, I can't control it here, for real. Let's see. Better, worse. Let's see what I can do about this. Better? Okay, there's one of me. Yes? Better? Okay, there's one of me. Yes? God damn. Alright, hang on. Let's try this again. Two of me, shoot. Okay, maybe I just have to. Try that. Let's see how that works. Kappa, Kappa, Kappa. Alright. G, I don't know. Alright, is that better? Do I finally got this down? Yeah, so now I've actually shut that off. Can you hear me now? Yes? No? Okay, perfect. Alright, so finally got that going. Got that going on. Okay, let's talk about a few things here, everybody here today. Thank you very much for coming out here during these circumstances. I appreciate your time and for coming out. Obviously, it's not a situation everybody wants to be in, but it kind of is what it is. What I want to let you know is kind of give you a bit of an update in terms of what we're going to be doing. Now, I did mention this in class last week. Yes, this is 103. Yes, that is correct. That's just my channel has more views than yours, so that's just because I'm just that amazing. Now, what I want to talk about here today is giving you an update on the class and what's to be expected. Now, all the homework is still posted on Connect Math. All right, so
Connect Math is going to be, again, where all the homework is going to be, and I've decided that's where the test is going to be in the meantime while the college is still closed until the 12th next month. I will be posting a test here now. One thing in regards to the test here is that will be due at the end of the semester. Okay, so like I've put on most of tests, there's no time limits. You can take your time. You basically have to do it in one shot, but again, you can take your time through every problem. There's no time limit on any problem whatsoever. You can again, pretty much do what you want with those tests. Hope, and that will of course count for a grade. Because at this time, that's kind of what we're working with. I don't really have much outside of that. I hopefully at some point I'll be posting notes here. There's the regular handout stuff that you see on the screen. We're posting up handouts there starting soon. I'll put that on Blackboard. Okay, so that's what the plan is going to be here essentially at the end of the day. So I'll post those handouts on Blackboard, and then you can reference those and print them out or do whatever you want to do with them. It's totally up to you at the end of the day, and that's perfectly fine. That's what I have for you so far. We're just going through the lessons here just as normal. I'm just going to be doing just a little bit per day. I want to also say that again, next week we still are going to be having spring break just as per usual, so I will not be streaming here next Tuesday and Thursday. I will be streaming here today and Thursday, and then following spring break I'll be streaming once again here for the remaining classes for the semester there. If we do get a announcement from the college here saying it's safe to return, you certainly will be the first to know if you haven't received any email notification from them. If I receive something beforehand, I'll certainly pass that along to you in another video. Are there any questions so far? If you're, again, post in the chat. It's the only way I'll be able to interact with you. If you're not sure about something, please ask any questions in along the way. There's a slight delay, but I will be kind of stopping at middle points here during the stream here. So I do apologize ahead of time if I sound a little bit like Dora the Explorer, but it's just due to the lag time there. But I want to be able to answer all of the questions that you may have. All right, so that's what's going on right now. Also, are there any questions? We won't be reviewing for tests like we normally would, because obviously I would be giving a paper-based test as opposed to a computer-based test. But if you do have specific questions you would like me to cover, I can certainly do that in regards to the test. Oh, that's a wonderful question. And what happens if we miss a stream? If you guys miss a stream for whatever reason, because life happens, it's all good. VODs for this stream will be posted on Twitch for up to 14 days after the initial stream. So I'll be labeling it, Math 103 and the respective day, and you can reference that right away. So if you happen to miss a stream, you can go back and watch the stream here once again, and you can certainly, talk about, actually just look at the stream there, and then obviously you won't be able to interact with me, but again, you can rewatch the stream at any moment in time to relearn any of the material that we went over that day. When is the test? Okay, so the test here is going to be on Connect Math, and again, that will be due at the end of the semester. Okay, so we're not going to be doing any in-class tests as of this moment, obviously, because, well, nobody can get to class. Yeah, all of them will be posted online. I'll certainly let you know once I'm able to do that. I'm still working through the process of doing that. I had a few issues yesterday, so hopefully I can smooth out those issues today on Connect Math and get that posted to you ASAP. So I'll let you know. Hopefully by Thursday, I'll let you know about what the story is, and yeah, then you'll get an update on that. Um, does anybody have any other questions? The test is due in May. Um, so, uh, mm, where's the Dunkin'? Yeah, I know. I do need to go to Dunkin'. You're right. Um, tell you what. I will. Let me see if I got something here. So, see, I got the Dunkin' app here, and I still have a little bit of money to spend on the Dunkin' app. Let's see. Well, I got one free beverage. That's actually kind of good. See, I got I got $21.13 on my thing here. I know it may be not easy to see there. There you go. Yeah, that's on the app there. Hopefully, I'll get that on Thursday, and we'll we'll pog champ it up. That's not a problem. Um, are there any other questions that you guys have for the math class specifically? Okay. All right. So let's go ahead and get started here for today. All right. Welcome back to Math 103. All right. This is gonna be fun. I'm pretty sure. This is gonna be fun. Hopefully. Okay. So you guys see up here on the screen, you see my setup here. Oh, that's what's happening there. All right. All right, so today we're going to be going over here section 4.1. Again, if you want to follow along, you can get onto Connect Math and reference the electronic textbook, which you should have access to if you've signed up for Connect Math. Most of you have, so you can reference the pages that I may be referring to at some points during the lecture. If you need to follow along there, please feel free to do so. In the meantime, however, let's go ahead and get started here with today's section, which is talking about inverse functions. All right, so inverse functions here. We're going to be first talking about a few concepts fundamentally, and we're going to be using, of course, previous concepts from before just a little bit. In order to actually understand inverse functions here. Now, let's go over the first question here. All right, and I'll make this a bit bigger here. All right, so first question here is, what does one-to-one mean? So we're going to talk about one-to-one functions here for today. Now, the book has some sort of definition in relation to this, but I'm going to go with a slightly different way. Now, if you remember when we talked about functions, when we first defined functions here, we had little boxes, right? We had one box for x and one box for y. All right, so we kind of had two boxes, like this was a box, this box here, on this math type thing could be the x, and then we had another box there that could be for the y. And we had one arrow, basically one x value, go from one x value going directly to one y value. And we said, all right, as long as we had one x value not go to two y values, that's not a function. And that's fine. Now we want to expand this definition here just a little bit. All right, so let's go ahead and show off what we mean here. So what exactly does one-to-one mean to me? One-to-one mean to me basically says this. This is where one x value goes to exactly one unique y value. All right, so the key word there, as you see highlighted, is unique. All right, one unique y value. All right, so there's the difference. The difference, it has to be unique, meaning to say that even the y value can't even repeat, okay, a second time around. So let's take a look at a couple of examples here, and we'll go ahead and see exactly what we're looking at when we talk about this definition. So let's say we have a set of stuff here. So let's go with a few points. Let's say this. Okay, so 3 comma 2, negative 3 comma 4, and let's go with 4 comma 3. All right. Now, if we take a look at these 3 points, all right, would these 3 points reference a one-to-one function? Say if this was a function just with 3 points, would this reference a one-to-one function, yes or no? Okay, one person says yes. Anyone else? Again, type your responses in the chat. That's okay if you're not sure. That's not a big deal. Okay. Somebody said yes, some of you said not too sure, maybe. Okay, let's take a look at each individual point, okay? So even as a simple example like this, it'll highlight exactly what this definition is talking about. All right, so here we have 3. 3 goes to the y value of 2. Okay, so basically, I cannot have another x value point to the y value of 2. If that happens, then that's not a one-to-one function. Okay, so much is the same way as we repeated x values and we said, oh yeah, that's not a function. We want to go ahead and say, hey, we don't want to have a repeating y value either. I hope it's quality content. This beard is very good quality too. So I have this minus 3 there. So I have this minus 3 going to 4. So again, the y value didn't repeat. Okay, and that's okay. So again, we have 4. Again, the y value didn't repeat because the last y value was 2. And then we look here, we have 4 comma 3, and 4 comma 3. Again, 3 is not the same as 4 or 2. So again, we had no y value repeat twice. So this is indeed a one-to-one function. So this is 1-to-1. Sorry for the math stuff there, but hey, it's the thing. All right. So that indeed is a one-to-one function. All right. Let's go ahead and take a look at another example, and then I'll ask for questions after that. Let's look at another example here. So. All right, so looking at these 3 points here, is this a one-to-one function? Yes or no? That's correct. Okay, so absolutely spot on there. So now that you understand how it works if we just look at random points, all right? Wow, that's a very strong response there. Now that you understand how this works, again, you see 5 does repeat twice as a y value, and Yes, that indeed is not one-to-one. So this is not one-to-one for the same reason. All right. All right. So just to point out exactly how that works, you can see that at least with points there, it's not too hard. It's pretty straightforward. No problem. Okay. All right. Any questions so far about that? Okay, so let's go ahead and move on here to the next question. All right, so let's move on to the next question here, and I'll go ahead and make this a tad bit bigger. All right, here we go. Okay, maybe that's a little bit too big. Yeah. All right, there we go. How do we know if two functions are? Question there. So only the y's matter. Yes, only the y's will matter. If we're talking one-to-one. Obviously, x's matter if they're a function. If the x repeats, then it's not a function. If the y's repeat, it is not a one-to-one function. So again, you have to check the x's first and see if those points are a function. If those repeat, then yeah, then it's just not a function, period. But if it is a function and you check the y's and they repeat, well, then it's not a one-to-one function. So a one-to-one function is a very particular type of function. So you do the checks with the x's first, and then you check the y's, and then you can determine whether or not that is a one-to-one function or not, based on the definition that we have. Are there any? Hopefully that answered that question there. So. All right. Okay, so let's look at question 2 here. Question 2 says, again, how do we know if two functions are inverses of each other? All right, so how do we know if two functions are inverses of each other? So we're going to go back, and again, we are going to have two functions here. Specifically, we're going to have two functions here of f and g. Okay, so f and g are going to be our two functions that we're going to want to look at. And we want to determine whether or not those two guys are going to be inverses of each other. Now, in order for us to do that, we're going to employ something that we've already talked about before. No, you may not like it because, well, it's math. But what do we actually have to implement here in this case? All right. So the answer to number 2 is going to be this. How do we know if two functions are inverses of each other? We do two basic checks, okay? Two basic checks. That first check here is we use the composition function. So if you remember, what was the composition again? That was FOG of x, okay? So FOG of x. So remember, we did that in the previous chapter there, talking about not previous chapter, but maybe the chapter before that. We did a composition function there, kind of a function inside of a function. And if we do that composition of FOG of x, somehow, miraculously, this has to equal x. All right? Somehow, some way, this has to equal x. But not only that, it has to work the other way. So if I go GOF of x, so let's go out here. So if I go GOF of x, somehow, miraculously, that too needs to equal to x. So both of them need to equal to x here at the end of the day in order to prove that both functions there are indeed inverses of each other. Okay, so let's go ahead and do a few examples here, and let's see if these functions here are indeed one-to-one. Remember, they have to work both ways. So let's put a note here. I'll put a big note here. Note, it must work both ways and not just one way. Okay, so that's an important thing to remember. Only works one way, it doesn't count. It has to be both right? Otherwise, it's a no-go. All right, let's start off with some two functions here, and let's see what we got here. So go ahead and just wipe this out here. Go. All right. So I'm going to go ahead and put in both functions here. So just to start with, so f of x equals 5x plus 4, right? And we'll have g of x here, and we'll have that equal to, and put in a fraction new, x minus 4, 5. Okay. All right, so here are our two functions. F of x equals 5x plus 4, and g of x equals x minus 4 over 5. All right, that's what we got here so far. All right, now what we're going to do next is we're going to see we're going to see both ways here to determine whether or not these are indeed inverses of each other. All right, so first and foremost here, let's go ahead and do FOG of x. All right, so really quick here, before we move on to the rest of the problem here, exactly what is FOG of x? What's the definition of FOG of x again? Go ahead and put your answer there in the chat. What Josh said. Okay, I gotcha. All right, that's correct. Okay. All right. So f of g of x is correct. So again, f of g of x, okay, is correct. So what we're going to do here specifically, again, we're going to first plug in g of x into f of x. Now, what does that look like here? So that's what this is going to look like here specifically is, let's see, where is this? All right, so I'm going to go ahead and put in the definition here of g of x. So that's x minus 4 over 5. Okay, so that's f of x minus 4 over 5. So remember, we're going to put this x minus 4 over 5, this thing that I'm circling with my mouse here, we're going to put that in for x in f of x. So we're going to put it into this x here in f of x. All right, and we're going to see what we get. So let's take a look at what happens when we do that. So we get 5 times, and just using our definition from before. All right, yep. Move this over here. There we go. All right, so we get x minus 4 over 5. All right, and that's going to be, let's go ahead and reference back to, again, we get, I believe we get plus 4 there. Yep, we get plus 4 there. All right, so plus 4. All right, so let's take a look at what we have here. Now, if you can see here, this 5 and this 5 will cancel each other out. All right, so after that point there, that's going to equal x minus 4 plus 4 after the 5's cancel out, and minus 4 plus 4, those two will also cancel out. So at the end of the day, this is equal to x. Okay, so that's what we have here. So indeed, as we can see here, FOG of x after doing all that manipulation is going to equal x at the end of the day. So again, we've proven one half of the statement that they're inverses of each other, but we haven't proven the other half. So remember, we have to go backwards as well. Before I do, are there any questions here so far? Okay. Alright, so there are no questions here so far. I'll go ahead and move on to the next part here. Alright, so let's go ahead and do GOF of x. So let's go ahead and type that in. Alright, so using the definition that we have from before, we're going to have G of f of x. Okay, so G of f of x is going to be the definition of GOF of x. So using, again, just reversing the letters around here. Again, remember, order does matter. Okay, so don't forget about that. Alright, so let's go ahead and see what happens here in this case when we do GOF of x. It'd be probably helpful if I move that up a bit. There we go. Looks a bit better. Alright, okay. Okay, so in this case, we're going to have G, and in of this case here, we're going to have 5x plus 4. So G of 5x plus 4. So we're going to put 5x plus 4, this thing that I'm circling in here, and we're going to put that into G of x. So we're going to plug that into this x here in G of x. Alright, so let's see what that looks like. Alright, oops, too far. Alright. So what this looks like here is this is going to look like let's see what I got here. Put parentheses here. Oh, right. Maybe it would be helpful if I do that. Here we go. So here we got 5x plus 4 minus 4. All right, and all that over. All that's going to be over. Hey, dude. Ay. This is what happens with technology and me. All right, so I meant to put this over 5. All right, there we go. All right. Blah. All right. So this is what we have here so far. Now, as you can see here, we're not distributing anything. We're not doing anything very unique here. So this is going to equal, again, this 4 and this minus 4 cancel out. So what I'm left with here is I'm left with 5x over 5, okay? And then the 5's cancel out, so then at the end of the day, this just leaves you with x, and there you go. You have now proven the second half of the argument here, so now you can say that both of these are inverses of each other. Alright. Are there any questions about that so far? Can I do another question? Yeah, sure. I can certainly do another question. No problem. Alright. Before I move on to that, before I move on to another question, does anybody else have any other questions? Go ahead and put that in the chat if you're not sure. Also, it's helpful if you put no in the chat because then I don't know. Wish I knew, but all right. I prefer face to face, but it is what it is. All right. Okay. All right. Let's go ahead and do another example here. So I'll go ahead and do another couple of guys. So let's put a couple of guys up here. So let's put f of x here first. We'll put to minus 2 plus x, and we'll put that over 6. Alright, so that'll be the first one there. And then we'll have the other one here as g of x. G of x here equals 6x minus 2. So 6x minus 2 will be our second function, just like so. Okay. Okay, so I'm going to paraphrase just a little bit here, so it does make a little bit of sense here. So after we have these two functions, we're going to first go ahead and do FOG of x. All right, so let's just do FOG. All right, using the definition that we talked about before, having that to be f of g of x. So again, so we're just going to have f of g of x. All right, so again, what does that look like? That's going to be f of, again, 6x minus 2, okay? All right, so 6x minus 2 here. So we're going to take this 6x minus 2, all right, and we're going to plug it into this one right here, this x that we see here. All right, so let's go ahead and see what happens here in this case. So we have here negative 2 plus 6x minus 2. And we have that all over 6. Again, hello. Sorry about that, everybody. All right. Okay, so let's go ahead and take a look here at what we have. All right, so we got minus 2 plus 6x minus 2. All right, and that's going to be, again, negative 2 plus another negative 2 plus 6x. So what we have here is we actually have here in this case, again, just looking at the fact you have two negatives there, that's minus 4 plus 6x. And all that is going to be over 6. So this, unfortunately for us, does not equal x. Okay, so and that's because of that little bit of extra negative 2. So it's already failed one half of the statement of how we can determine whether or not two functions are inverses of each other. So in this case, this would be a big fat no. These are not inverses of each other here at the end of the day. Are there questions about that? Once it fails one side, you don't need to go any further, by the way. It just needs to fail once, and then the whole thing fails outright. So less work for you to do at the end of the day. How did I get minus 4? So take a look here. We have minus 2 and another minus 2. Again, we said plus, again, plus in this case at the top here. So we had negative 2 plus x. If we had negative 2 plus x here, and then we had negative 2 plus another negative 2, and that's negative 4 there. How do you know it fails again? I don't. If I go backwards, I can see if it does fail again or not. It could work one way, and it may not work the other way. It could fail again, but it could fail again if it does. But again, at the end of the day, you know it will fail if it fails just one of these composition functions. So if we get FOG of x, let's go down here. If it does not, if it does, that's let me move that over. Sorry. If it again does not equal x, if one side does not equal x here at the end of the day, then the whole thing is going to fail. So just one of these composition fails, then you can just assume that it's not a one-to-one function. But you have to test if one does work, then test the other to see if that works. If that doesn't, then it's not a one-to-one function. If it does, then it is a one-to-one function. So again, you're still going through these same two definitions that we had from before. Okay. In this case, this is where we knew where to stop, since we did indeed get not being equal to x there at the end of the day. Yes, that's correct. You do not, if it fails FOG, you do not need to do GOF. If it could pass FOG, but it may not pass GOF, in which case that's still not a one-to-one function. Right. So very convenient in that regard. Is like, well, hey, I don't need to do like extra work. It's, once it fails once, that's it, I'm done. But if it passes, then I still got to keep going, just like the first example. Any other questions? No? Okay. If you like Twitch, yeah, Twitch is nice. Twitch is very, very good. I like it very much. It's a nice medium. Very good question. So it'd be a one-to-one function if one function works while the other one doesn't? No, it has to work both ways. So it has to be both ways or it doesn't. So essentially you have to check FOG and GOF. So you can't make the assumption that if it works for FOG, it's going to be a one-to-one function. You have to test both definitions. So that's why I've put the note here. Again, it must work both ways and not just one way. All right, so yeah, I just want to clarify that with you, my friend, just to be sure that again you understand that, yeah, if it works one way, you're going to try the other way, GOF, and see if that works or not. Are there any other questions before I move forward? Nope. All right. All right, very good. All right, let's go ahead and move forward here. Okay, so let's answer the next question here on the agenda. All right, so let's make this a tad bit bigger here, of course. All right, there we go. So how do we find the inverse of a function? So how do we find the inverse of a function? All right, so what we're going to do here specifically is we're going to want to find the inverse of if we want to find the inverse of a function, we're going to go through various steps here in order to do so. So let's take a simple example here to start with, and then we'll kind of work our way forward here to see exactly how it works. All right, so okay. All right, so yeah, this go here. Okay, so let's take our function in hand here. So our function in hand here, in this case, is going to be. Let me make this up here. Yeah, let's go with something simple like. Yeah, let's go with my classic 3x minus 2. Okay, so everybody likes 3x minus 2 because it's easy. All right, so I want to go ahead and I want to figure out the inverse of this function here. All right, I want to be able to do this and kind of get it pretty quick. All right, so here's what I'm going to do. I'm going to write out the steps over here. So let's go ahead and start with that. Okay. All right. That doesn't look too bad. Let's try again. There we go. There we go. All right. So let's go to step 1. All right. Step 1 is, remember what we talked about here before. We have said when we first introduced functions, we said that f of x is the same thing as y. All right? F of x is the same thing as y. And actually, in this case, that's going to prove to be very beneficial and very helpful for us. All right? So what we're going to do here first is we're going to change f of x to y. All right? So what we're going to do here first is we're going to change f of x to y. So here in step 1, we're going to go ahead and say y equals 3x minus 2. Okay, so that's step 1, just like so. Alright, that's all we're going to do right there. Okay. Okay, let's move on here to step 2. So step 1, not too hard, a nice little cosmetic change. But step 2 is where things start to go, ramp up a little bit. So let's take a look at that. Alright, so step 2 here is going to be, we are going to actually physically swap all the x's. We're going to change all the x's to y's and all the y's to x's. Alright? So we're going to change all the x's to y's and all the y's to x's. Alright, so we're just going to make a little bit of a swap here in step 2. Okay. So, good. So we're going to have x equals 3y minus 2. Alright? So that's what we have here so far. Alright? Okay. And remember, one thing to keep note about here is that every x has to be changed to y. Okay, so if there are multiple x's in the equation, yes, every single one of those x's must change to a y. That's important. Alright, step 3. Step 3 is what we want to do after we swap everything out is we want to go ahead and we want to solve for y. Solve for y. Basically, that's essentially what I want to do. So after swapping everything around, we want to go ahead and solve for y here again. Alright? So let's take a look here and how we can do that. So, in this particular case, let's go to the next part here. Alright. So we have currently x is equal to 3y minus 2. So what we're going to do here is we're going to go ahead and add 2 to both sides here. Okay, so we're going to, I'll just go ahead and put these in parentheses here, like kind of let my, what my algebra is going to be. So I know that looks a little strange, but again, this is just to show you, what I'm kind of doing here at this point. So I have x plus 2 equals 3y, okay, after adding 2 to both sides. And then I'll go ahead, I'll put this in parentheses here. Not brackets, bro. Parentheses. Okay, there we go. So go ahead and, I'm not sure why I did that, but yeah, just, the jank is real. Alright, so next we're going to go ahead and divide by 3. So we'll divide by 3 here, and we're also going to divide by 3 as well on both sides. Okay, and finally, at the end of the day, we're going to have this as our expression. So let's put this down. Okay, so we're going to have x plus 2 divided by 3 is equal to y. Okay, so that's what we have here after doing some simple algebraic manipulation. All right, are there any questions so far? You're confused from step 2? Which part, my friend? This is adding 2 to both sides. So basically all I did was I have minus 2 here. I just added 2 to both sides here. So that's what this reflects right here. Okay? It's just adding 2 to both sides. And then the subsequent result was x plus 2 is equal to 3y. And then I divided by 3 on both sides to get this expression. So all I did was just do some simple algebra to get back to y here again. Does that make sense? Hopefully. Alright, cool. All right, great. Now, the next thing that we're going to do here is there's just one more step, and this last step is more of a cosmetic change. Oh, scroll up to step 1? Sure, absolutely. Here you are. So let's go to step number 4 here. One that's not bound. Okay. All right. So step number 4 here, what we're going to do is make a slight cosmetic change here. All right, and exactly what is that cosmetic change? Well, we want to use the notation here for inverse functions, okay? And let's talk about that notation here. What we're going to do is we're going to change y. So let me go ahead and write this down. We're going to change y to, and in this case here, we're going to have f to the minus 1 of x is going to be the notation here for the inverse of this function. So make this a bit bigger. All right, so we're going to change y to f inverse of x. All right, so this little guy here is the notation that we're going to use specifically for our inverse functions at the end of the day. Okay, so that's what we're using here in this case. All right, so basically our final result here is going to be just exactly as you see up here. So let me go ahead and put that in. So we have f inverse of x is equal to x plus 2 over 3, and that's going to be our final answer for this problem. I'm going to go ahead and do another example here, but before I do, are there any questions? Oh, well, that's not too bad. Nope. Okay. All right, let's go ahead and give another question a try, and we'll see how things work out this way. So let's see. I want to try a slightly tougher one here, because some of these problems here can throw you for a loop. So I want to be sure that everybody's kind of on board with this stuff. Okay, so I'll just go ahead and erase that there. All right. Yes, I think that one looks okay. So let's go ahead and use that one. Okay, so can I undo that? Is that possible? Let me see if I can undo that. Give me just a second here. There we go. This is the example here from the beginning. This right here. Scroll up here for just a second. So just make note of that. Actually, I should probably just move this down here. So all right, there we go. Okay. Go ahead and delete that there. So here's what I'll do. If you want to see this example again, I'm just going to go ahead and copy paste this over here. There we go. Alright, now I'll make that a bit bigger so you can follow along if you missed out on the thing. Alright, so there we go. All right. Is that a bit better? Is everybody cool with that? I want to be sure that everybody's. Like I said, I'm still trying to work the kinks out, so I apologize if. All right. So let me move on to the next example there. Again, if you missed the previous example, here it is on this right-hand side here. Okay. So let me repost that example there, and we'll start with that. Where was it again? Okay. Why did that happen? Okay. So we have x minus 4, x plus 2. All right. So this is what we have here. All right, from for our second example. All right. So let's go over each step here one more time. Okay. So here we have step 1. We're going to change f of x to y. All right. So from our first step here, we're going to have y is equal to exactly what we have up here. All right. So we have y is equal to x minus 4, x plus 2. All right. So what do we do next? What should we do next? Go ahead and answer in the chat there. All right. So switch the x's with the y's and the y's with the x's. All right, cool. All right. So what's that going to look like if I do that? Okay. Very nice. All right. Very nice. Everybody's correct. All right. Very good. So x is equal to exactly correct here. Very nicely done. You get y minus 4 and y plus 2. That's right. Nice. All right. Okay, so all right. So now remember, we got to solve for y next. Okay, that's what we got to do. Okay. So what do you think I need to do here first? How am I going to be able to solve for y here? Think about it for just a second here. So you're like, what should you do first here? How are we going to be able to solve for y? Yeah, no, this one's a little tough. I totally understand if you're not sure. This one's intended to be just a little bit harder, so, well, I guess a lot harder. But that's okay. It's just, again, a very different look on how to do that same exact, how to do this problem here. Yeah, I'm with you on that one. I'm with you on that one, Irvin. Totally with you on that one. The madness, I tell you. All right, so okay, so let's go over this example here. So maybe you're not sure. That's perfectly fine. All right. So how do we go ahead and approach this? Well, turns out the first thing that we're going to do here specifically in this particular problem is yes, lots of dog emotes. First thing we're going to do here specifically is we're going to go ahead and we're going to multiply by oh, I just messed that up there. We're going to multiply by y plus 2 on both sides. Okay, so that's the first thing that we're going to do here in this instance, is multiply by y plus 2 on both sides. Okay. All right. Okay. So this y plus 2 and this y plus 2 are going to cancel out. And so what are we left with here? We're left with x times y plus 2 equals y minus 4. All right. So this is what we're working with here so far. All right. So multiply by y plus 2, and this is what we got. All right. Now, the next part here is the toughest part. Okay. That part is already tough enough. I'm not going to disagree with anybody here. But how do we deal with this next part here? Okay. So remember, we want to get y is equal to something, something, something. Okay. That's the mindset that I'm working in. All right. What that means is, to me, I want to get y by itself on both sides, or on one side, I should say, not both sides. Boop, boop, boop. All right. So what I want to do here first is, if I'm going to get the y by itself, I'm going to first go ahead and distribute this x that I see here. Okay, so I'm going to have xy plus 2x. All right, so I'm just going to distribute that x equals y minus 4. Okay. So that's what I have here so far. Are there any questions here so far? I know it's a little confusing, but that's okay. But I'll stop here for just a second. Does anybody have any questions? All right. So let's take a look here at what we should do next. All right. I want to get y by itself. So in order for us to get y by itself, at this moment in time, we have a y on both sides of the equations. This is not ideal for what we want to do. So in order for us to change it away from that ideal, what we're going to do is we're going to move everything that's not y to one side of the equation, and everything that it has y's in it, we'll move out to the other side of the equation. So what do I mean by that? Well, I'm going to go ahead and I'm going to add 4 to both sides here. Okay, so let's do that. So I'm going to add 4 to both sides. And I'm also going to go ahead and subtract by xy. So I can subtract by xy here, and I can see what I get here. So let's go ahead and do that there. We'll I guess I'll just put that out here. Minus xy. Okay, I know it looks a little confusing. So Alright, let me scroll over here. Okay. So, what do we get after we take away both of those guys? Alright, so one more time. I added 4 to both sides. Okay. So I added 4 to both sides here. And I subtracted by xy on both sides as well. Alright. So that's what I did. That's what I did here, Humo. Is I just went ahead and just want to have all the y's on one side and everything else on the other side. That's what I wanted to do. So I'll show you what we come up with after I move all that stuff around. So on the left-hand side, I get 2x plus 4. That's what I get here on the left-hand side. On the right-hand side, I get y minus xy. Okay? So all this stuff up top turns it into this, essentially, after doing some algebraic manipulation. You got a question about that? I want to make sure that things are clear here. Alright, cool. Okay. Now, if you take a look at this here, alright, so let's take a look at what we have here. Let's take stock. Alright, this is what we have here so far. 2x plus 4 equals y minus xy. Alright? How can we solve for y here? What do you think I should do next? What do you think I could do next here after we get down to this point? Add xy to both sides? No, that would go right back to where we started from. So I don't think we want to do that. Again, we want to get y by itself, right? So moving xy to the other side wouldn't change anything again. There's a reason why I subtracted by xy on both sides. What do you think we could do here? Yeah, actually really nice. No, that's correct. We could factor out a y, and y times 1 minus x. That is absolutely correct. Very nice. So we're going to have 2x plus 4 equals, and then we want to go ahead and factor out the y here. Alright, because if we factor out the y, we get 1 minus x here as a result after factoring out the y. And the reason why we want to do that is now we can effectively get rid of anything that's attached to y at this point by dividing by 1 minus x on both sides. So we're going to go ahead and divide here. Oh, why did that happen? Do typing, please. Do template. Right, there we go. Ah, that's why that happened. And we'll go ahead and divide by 1 minus x. Okay. And so we're going to find out what our final result here is going to be. So our final answer here, after everything is said and done, is f inverse of x. So our inverse here is going to equal the quantity 2x plus 4 over 1 minus x. Okay, and that's going to be our final answer. So let me go ahead and reiterate here. I know you're confused. I know you're confused, and I want to properly explain things. So the reason why we wanted to, again, factor out the y here from this previous part is, again, this separates the y from the rest of the expression here. So we can just take this 1 minus x, and then we went ahead and divided by 1 minus x on both sides. Remember, our inverse function here should be in terms of x here at the end of the day. All right, so I don't want any y's in my inverse function final result here. All right, so we want to, again, that's the goal here, is to get y by itself. It's a little bit of a tougher process with two y's kind of floating around at the same time, but again, if we gather them all together and then we are able to factor it out, now it becomes a significantly easier task to do. Once we were able to go ahead and take out that 1 minus x, we can just do some simple algebra and go ahead and move it over to the other side. All right, any questions about that so far? I hope that makes sense. Yeah, online school, man. Crazy times, I tell you. Oh, that's cool. I appreciate that, man. Hey, man. We all gotta make do with what we got. This beard's not getting any thinner. Okay. Yeah, I probably could use some chips. I do have some chips down here that I could eat right now. It does sound pretty delicious. All right. Heard Cheetos were cheap at Jewel. All right. Anyway. Okay. Let's keep going here. All right. Let's keep going here. All right. Let's move on to the next part here. All right. Okay. So next, let's go ahead and say, how do we know if a graph of a function has an inverse? How do we know if a graph of a function has an inverse? Okay, so that's the next thing on the docket here. And yeah, man, that's absolutely spot on. You got it. So let's go ahead and at least describe what that means. The horizontal line test, right on. So let's just make this as easy as possible. Alright, so what is the horizontal line test? Well, it's like the vertical line test that we did when we talked about functions here from before. Alright, so it's fairly straightforward. So instead, what we do is we, again, draw a horizontal line. So horizontal line anywhere on the graph if it touches two or more points, then the graph does not have actually I should be a little more clear here, does not have an inverse. Okay, so pretty much how do people know this? Very, very carefully. That is the answer to all things. Alright, so draw a horizontal line anywhere on the graph if it touches two or more points and the graph does not have an inverse. Alright, so let's take a look at some graphs here. So I got a little graph app here for this. So let's go ahead and bring this up here. Right. So let's take a look at some graphs. Let's take a look at this. Alright, so does this graph here, our basic y is equal to x graph, does this graph here have an inverse? Yes or no? Alright, yeah, that definitely does have an inverse, okay? No question about it. Let's look at another one here. Let's go ahead and change this graph up here a bit. All right, how about this? All right. Yeah, the answer to this one is no. Okay, so again, remember that horizontal here means, again, cutting across like a horizon, like a sun's horizon. So again, cutting across like this. If we cut across like this, all right, this way, we're going to hit 2 points here and here. All right, those 2 points, that is okay. That's okay, man. Hey, that's what we're here to do, man. We're here to cover stuff. It's all good, man. It's all good. So I'm here to help you out with. I collect the tears, okay? I do collect the tears. All right. So this function here, parabola, y equals x squared, actually does not have an inverse. Okay. Again, drawing a horizontal line. If I drew a horizontal line of y equals, let's say y equals 2. If I drew this horizontal line, notice that this would touch at exactly 2 points. Okay. So it can't hit 2 points or more, so that's a definite no. All right. Let's take a look at one more here. How about this one? Does this graph have an inverse? Yeah, that definitely does have an inverse, okay? So again, this definitely has an inverse here. You could draw any horizontal line that you want, all right? And again, it'll only hit 1 point here, even on a sideways parabola. This isn't a function per se, but this is indeed this graph here indeed has an inverse. Okay, so the answer to this question here is yes. This indeed has an inverse. All right. Questions here so far? A is right. All right. So all right. There we go. I just had to write that in for you, buddy. All right. Totally worth it, man. Why? Why? Of course I gotta do that, man. What? What else do you want me to do, bro? That's just how it rolls. the question is, why not? That's the question you should ask yourself. All right. All right. Let's take a good look here at this next question. I know. All right, next question here. What do we have to remember when graphing an inverse function? Hey, how's it going? How long does class go to? Technically, we're done, but I need to do at least this one last question here. So if you allow me to go ahead and do this one last question, then we can end off here, and then I'll restart here from the last question here of this handout. Because I know it takes a little bit longer to just kind of get through stuff due to the fact we're online. So it's all good. It's all good. So, all right. Okay, so what do we have to remember when graphing an inverse function? Inverse functions. Let's do it. All right. Okay, so the one thing you have to remember regarding inverse functions is if you have an inverse function, let's say, let's kind of go back to our last one here. So let's say, again, I used the equation here before. X is equal to, again, 3x minus 2. Okay, so that's what the graph looks like here. Again, just a regular line. This indeed has an inverse function. We actually already have seen that. All right, from before. All right, so in this case, if we're going to go ahead and see what the inverse function is going to be, we already saw what the inverse function was from before. I might have erased it from before, but what was that? Off the top of my head, let's see, that's x. So we had x plus 2 over 3. All right, so do that in my head. All right, so we had x plus 2 over 3. All right, so take a look here. This is the one in the gray here is going to be 3x minus 2, and the other graph here is x plus 2 over 3. That's the red line that you see here. All right, so having said that, all right, both of these are indeed inverses of each other. But what's interesting is that you can easily graph the inverse function, and this is what you have to remember here, is that you are going to go backwards on your XY chart from the original. So what that means is that if we look at our original function here of f of x is equal to 3x minus 2, something simple like that, we have a regular xy chart here. Okay, so with our regular xy chart, we plug in some random numbers, right? So I'm going to look at the gray line here, and I say, all right, hey, what's the value at 0? All right, so the value at 0 here is minus 2. All right, so I got 0 here. Wow, that's a really tiny 0 because I can't even see it. I gotta stop being blind. I got 0 comma minus 2 as one of my points. Now, let's go ahead and pick another point here. If I pick, say, let's say I pick 2. So 2 here is going to be 4. All right, so we have the other point here, 2 comma 4. So we plug in that point there of 2 comma 4. Hey, bro, let's do this. Bam. All right. Man, you don't want to cooperate with me. All right, that's fine. I'll make you cooperate. There you go. No? Yes, no? All right. There we go. Got it. All right. So here we have a point here of 0 comma minus 2, and we got another point here of 2 comma 4. All right. That's what we got here going on so far. But my contention is if we look at the inverse function, so look at the red line here, okay, that if we go backwards, so instead of going from x to y, so instead of going from left to right, instead you're going from right to left. You're darn right it's math. All right, so to go backwards here on our inverse function, all right, so the inverse function here, so I'll just put inverse. The inverse function xy chart is going to look like this. So instead of 0 comma minus 2, you're going to go backwards here and just go from right to left. So at minus 2, you're going to get 0. So I pick minus 2, so instead of going left to right, again, I'm going right to left, so I pick this guy, and I know what my answer is going to be. I'm going to get 0 here. If I pick 4, because that's this value here, I can go backwards, and I get 2 as my other one here. So again, I go negative 2 comma 0 going backwards, and 4 comma 2 going backwards. I mean, heck, I can pick literally anything that I want here. So I could pick, say, let's say I picked minus 1. If I picked minus 1 in my original function, I would get minus 5. All right? So if I picked minus 1 and minus 5, what would be my inverse point then? So if minus 1, minus 5, now minus 3, but minus 5 is correct, and minus 1, that's right. So just going backwards there, right? Just take again, instead of going 0, comma, minus 2, go backwards, minus 2, comma, 0. Okay. I would be kind if you don't swear in chat, please. That would be very nice. Don't worry if you got it wrong. That's not a problem. All right. So minus 5, comma, minus 1 is that's okay, man. Hey, it's all good. Hey, we're here to learn. It's not. Don't be mad at yourself. That's not a big deal. We're here to learn. I'm not here to kid. I'm not here to make you angry. So all right. So you get minus 5, comma, minus 1. And that's going to be, again, let's take a look back at our graph here. Let's take a look at minus 1 here. Because let's look at minus 5, I should say. So if we look at minus 5 here, we can see that we indeed get minus 5, comma, minus 1. And there we go. We got it. All right, so you can see that actually making an inverse graph here is fairly predictable if you already know what the original function is going to be. So just take a look at the xy points, go backwards, and be able to put one together without any trouble. All right, does anybody have any questions about that? Sorry, I kind of had to. All right, so I'm going to end off here for today. I'm going to be back in. I'm going to be back in 15 minutes or so to do another 103 lecture. All right, so if you missed anything here from this first lecture, I'm going to be putting up another 103 lecture for my other class. All right, everyone. I really hope you enjoyed today's first kind of online class here today on Twitch. All right. I hope everyone has a very wonderful day. All right. Stay safe, stay warm out there, and I will see you all in a couple of days. Thank you very much for being. Thank you very much for taking your time with me. I really appreciate it very much. Is the test available? Is the test available? Yeah, the test will be available here in a couple days. Once I got everything put together, I'll let you know. Hey, thanks. I don't even trim my beard. It's kind of amazing. So that's essentially what's going to be going on here. I'll be putting up the test here in a couple days, and I'll let you know when that's available for you to go ahead and start. Yes, the next session will be here on Thursday at 11 o'clock. All right, so we'll see you all guys later. All right, have yourselves a great day. All right, get some food in ya. All right, have a good one, everyone. Take care of yourselves.